Hey, how you doing out there? It's nice to see you again. Welcome back. Let's learn about exponents. I'm going to try to make a fast video. I'm going to try to keep it under 5 minutes. Oh man. Hey, someone could dream, right? You could dream. We're going to talk about simplifying exponents. Kind of specifically focusing on this power rule, but we'll try to do some complicated examples if we have time for it. But before we begin, I do want to ask you a quick question. What's your bright spot today? All right. My bright spot, I think it was, I had a good night's sleep. I don't know. I had a good night's sleep last night. So I'm going to give that, I was nice and warm. It's been freezing outside. So I kind of enjoyed being nice and warm and cozy. All right. Well, let's get to this problem, okay? So the power rule basically just says this, that if you're going to take an exponent and raise it to yet a higher exponent, right? I mean, this base is raised to the third power and then raised to the second power. You multiply those exponents. Beautiful. And that kind of stands a little bit in contrast, right? Because I kind of want to also kind of surface this real quick, is that these are different, right? Now, this is the product rule because we're multiplying, right? We're product. In this case, you add those exponents. So you just got to differentiate, right? Like this is an exponent raised to a higher exponent. This is a base with an exponent multiplied to a different base with an exponent. There's nothing like raised to a higher exponent. And in fact, if we just use what we know about exponents, i.e. something squared is a thing multiplied by itself, that this is really x to the third times x to the third, right? That's what x to the third squared is. So if we use this exact rule, we would go 3 plus 3, we would get x to the 6th. Oh my God, it's almost like we don't even need this rule, but this rule is a shorthand, right? It's faster. That was a lot faster than expanding it out and adding those exponents together. So with that, let me get another problem up there for you. Now let's begin. So this is like, it's a similar problem, and I want you thinking to yourself, Mr. Miller, how can this get more complicated? You should be pushing me. I dropped another marker. You should be pushing me like, let's get this as complicated as we can. Let's see, because I don't want to be tricked on some weird problem on an exam, right? So the key here is to realize that exponent to the 5th is connected to the x, not the 3. So I'm even going to change the color there. So we got x to the 5th. I'm going to use blue as a multiplier sign. And really, in a sense, remember, it's invisible math, but there's actually a 1 there, right? Because it's really 3 raised to the 1st power times x raised to the 5th power. So let's just use our straight product rule on each one. So we got to do it to the 3, and we also got to do it to the x to the 5th. Let's get it. So we're going to go 3 to the 1 times 4, which of course is 4, but I'm just going to show you as the 1 times 4, times x to the 5 times 4. So we're going to get here, and we're going to be at 3 raised to the 4th times x to the 20th. Grab the green marker, circle that, and say, I got this one, teach. I got this one. This is just the power rule. Beautiful. Let me think if I can dream up even a more difficult problem. Let's get going. All right, well, let's see what we have here. We've got, here we have exponents that are being raised to a higher power, right? So it's going to be the power rule. Over here are kind of invisible math, says we have that exponent of 1 there. So before I multiply this direction, I got to first deal with this exponent. Because remember PEMDAS, right? Like you got to do exponents before you multiply. So I can't go 4 times 2. Because that's not really a 2, it's 2 to the 3rd, right? So it's 2 times 2 times 2, so it's really an 8. But let's look at this further. Okay, so first move here, And let's bring out some different colors, I suppose. Start with the 2. So we're going to go 2 to the 3rd power. So what I'm kind of not showing there is, again, the invisible math says there's a 1, and 1 times 3 is 3. All right, next one, let's go switch to pink. We're going to go x to the 4 times 3. All right, so I got that one dealt with. Beautiful. I don't know if the colors are helping, but they're pretty, so let's just keep doing it. Y to the 5th, okay, so I'm going to go y to the 5 times 3. So I don't really need the parentheses anymore because I've dealt with that over here. I'm just going to bring it back down. 4 times x squared times y. Remember, if there's nothing outside the parenthesis is not required here. So we're just going to leave it off. And so let's now simplify this further. So let's go 2 times, I'm going to try to stick to the same color. So x is pink, so I'm going to use pink here. I'm going to use blue. All right, y. Should I show it to the first? Do I need to say that? Do I need to show that? Some math teachers would not be happy with me showing that raised to the 1st power. But they're not here right now, so we're good. I don't know why I wrote a 2 there when it's supposed to be a 4. I'm going to evaluate that because I know what 2 to the 3rd is. That is a mistake. Here I thought I didn't make mistakes. Oh my gosh. Oh my gosh. Oh my gosh, you mean everybody makes mistakes? Even you? Yeah, even me. It's okay. It's okay. I tell students all the time. It's all right. It's all right. We're just doing exponents here, really, right? We're just doing exponents. All right, so let's go over here. We got y, the 15th. We're almost there, I swear. So now I'm just going to multiply the bases that are the same. Now, 4 and 8 are obviously different numbers, but they're both integers, so I'm just going to multiply them together. Now I've got my x's, they're the same. So this is going to give me x to the 2 plus 12, which is 14. And let's finish over here. We've got y to the 1st times y to the 15th, which means we have 16 multiplications of y, or you just go 1 plus 15 is 16. And we are finished. Beautiful. Should we dare do another one? I think we should. All right, well, let's do this last problem. It actually has a division in it, right? So it would be using the quotient rule, but in the numerator and the denominator, we don't have any bases that are the same. So what we're going to do is we're just going to deal with the fact that it's all raised to the 2nd power. So let's just go ahead and square everything. So, it's worth noting that that's a multiplication. This 4 and x are both raised to the 1st power, and they're both going to need to be raised now to the 2nd power. So down here, what I'm going to do is I'm going to say 4 to the 1 times 2, which is 4 squared, times, we got x to the 1 times 2, which is going to be x squared, divided by, now I have to also do it to the numerator, right? So here it has to become 3 squared. Oh, multiplication signs are supposed to be blue here today. And we got y to the 4th. It also needs to be raised to the 2nd power, so it's going to be y to the 8th. Lastly, I'm just going to evaluate this because 4 squared is 16. So 16x squared over 9y to the 8th. This fraction can't be simplified any further. That means I get to go to my green marker. And yeah, exponents, they are what they are. It's not the most practical mathematics that we've ever done here, but it's good for what it is, aren't we all? So anyways, I hope this found you in a good mood, and I hope you keep studying. You're beautiful. You're gonna do well. And yeah, until next time, I suppose.